Okay, we're going to take a look now at what's called direct nth power variation. So this looks very much like direct variation, except that your function is equal to your constant of variation times x to a power n, or y is equal to k x to the n. Now the n here, the power, will usually be given in the problem. So let's take a look at this problem. Stopping distance of a car varies directly, so that tells us we're going to be using this, to the square of the speed. So the square gives us our n is 2. If a 60 mile per hour car stops in 200 feet, how fast can it go and still stop in 72 feet? So we have a car, we know that if it's going 60 miles an hour and hits the brakes, it takes 200 feet to stop. The question is, what's the greatest speed I can have and stop in 72 feet? Okay, so let's set up the actual variation here. Remember, we're going to be using one of these here. And it says that the distance varies directly. So the distance, okay, varies directly to the square of the speed. So I'm going to say distance equals our constant times the square of the speed. The speed I'm going to call s, and I'm going to square the speed. Okay, now let's use the information that we're given. If a 60 mile per hour car, that's a speed, stops in 200 feet, then I know that d, the distance is 200 feet, equals k times, now our speed is 60 miles an hour, 60 squared. Okay, now what I can do is I can solve for k. So I'm going to square 60 and then divide both sides. So 60 squared is 3,600. I divide both sides by 3,600 and I will get my k. So k will be approximately, let's see, 200 divided by 3,600, about 0.05, I'll say 56. So I rounded that off. That's approximately our constant of variation. Now what we'll do is we'll go back up to this. We know that our distance for this particular car is going to be equal to 0.0556 times the speed squared. And now what we can do is we can answer the last question. The last question was, how fast can it go and still stop in 72 feet? So what we're given here is the distance, 72 feet. We need to plug 72 in here and find our speed s. So I'll do that right here. I'm going to plug 72 in for distance is equal to 0.0556 times the speed squared. So the first thing I'm going to do is divide both sides by 0.0556. So 72 divided by 0.0556. I get about 1,294.96. That's our speed squared. And now we take the square root on both sides. So I do 1294.96. I take the square root of that. And I get about 36 miles per hour, approximately, or roughly 36 miles per hour. So we can see that if you travel 36 miles per hour, you'll be able to stop in 72 feet. And that makes sense because 60 miles an hour took us 200 feet. So that's how you'd use this direct nth power variation.